Alright, we're going to use basic anti-differentiation rules to find antiderivatives. So, the other day we talked about anti-differentiation. What is anti-differentiation? What did anti mean? Opposite. So anti-differentiation is the opposite of differentiation. So, in order to do the opposite of differentiation, I want to look at a simple problem and find the derivative of it. Because if you do anti-differentiation, we want to do the exact opposite of what we do when we find derivatives. So if I've got y equals x cubed minus 11, what is the derivative of that? 3x squared. 3x squared. Now, we did 2 steps to get to the 3x squared. What 2 steps did we do?
Bring the 3 out in front.
Multiplied by the 3, so multiplied by the exponent. And what else did we do? Subtract 1 from the exponent. So, what is the exact opposite of that going to be?
Add and then divide.
Add and then divide. So the exact opposite is add 1 to exponents and divide by exponents. So those are the 2 steps we want to do when we're doing an anti.
You do the anti-differentiation to the x cubed minus 11 or to the 3x squared?
The 3x squared, because if I do anti-differentiation of the 3x squared, then I need to end up back where I started. Okay? So, if I want to do the antiderivative of 3x squared dx, the first step is...
What do you do with the s?
Say it again.
What's the s? What do you do with the s?
That tells you what you're doing.
That means anti-differentiation.
Yes, that means I want to find the antiderivative of what's inside.
Okay, add 1.
Alright, so first thing I want to do is add 1 to the exponent. And the second thing we want to do is divide by the exponent. And if I reduce that, I get x cubed. So what's missing?
The
11.
The 11 is missing. So whenever we find an antiderivative, we're going to put a plus c out there when I'm dealing with an indefinite interval. Okay? Because what does the c represent?
constant.
A constant. Now, eventually down the road, they're going to give me enough information to where I can find that missing constant. But right now, when we find an antiderivative, we're just going to put the plus c on there. That way, we're showing that we understand that there is a possible constant.
What's the
behind this.
dx? What is that?
Were you here yesterday?
Yeah.
We're
You
just
didn't know this
finding,
yesterday.
so we
I
find
know,
the
but
derivative to not find the
It just
derivative.
means that
The
with
dx.
respect to x.
Yeah.
That means if I'm integrating something and I don't have a variable, then that tells me what variable I'm using.
Okay.
Such as like on down there when I want the integral of 4 dx. When I integrate that thing and I need to add a variable, I'm going to add the variable x. Rob?
Are we just finding the derivative and then not?
No. I'm finding the derivative and then integrating it so that we can understand the process.
We won't have to
Once
find
we
the
understand the process, then we're just going to be integrating, finding the antiderivative.
What are you going to do the next one?
Okay, we'll eventually get there, yes. Do you have some extra caffeine this morning?
No.
He just has glasses, so
He
we
stays
can
on
see
whenever
that.
he's fine.
Now, what is something I can always do to my antiderivative to see if I got it right? Check it. How am I going to check it? Find the derivative. If I take the derivative of this, it should always end up back what's inside of my interval. So the derivative of 3 or x cubed is 3x squared, and the derivative of the constant is 0. So you can always take the derivative to see if you did it correctly. Okay? Now the first couple of problems on your assignment are going to be, they're going to tell you to find the general solution of a differential equation. A differential equation is going to look something like this. Okay, this is what a differential equation is going to look like. When I've got that dy dx over here on the left and it's equal to a function that's on the right, that's considered a differential equation. So I want to find the general solution of this differential equation. Any thoughts on what you think that might mean?
Take the derivative.
Antiderivative.
I want to eventually take the antiderivative. I want to get it to where it's y equals something. So does anybody have any thoughts on what I want to do to head that direction?
Add.
Multiply by this.
Multiply by dx is what I want to do first. So I want to multiply that dx over there. I multiply by that dx. Once I multiply by the dx, then I want to integrate both sides. What am I going to get when I integrate dy?
Y.
I'm going to get y. Okay, so then I've got that 5x squared. What's the first step?
Add.
Add 1 to the exponent, which is 3, and
Divide.
divide by it. Okay, then what about that 3?
Add an x.
I need to add an x to it. So if it's just a constant, you're going to stick the variable on it. Okay, so what is my actual exponent of that x?
1.
1, so if I divide by 1, nothing changes. So that's why it's just adding the x to it. Now I've got to do one more thing before I'm done with this problem. I need to do my plus c. Okay, and that is the general solution of the difference equation. So you want to kick the dx over, you want to integrate both sides, make sure you do the plus c. So that's what the first couple problems are going to look like when you get it.
Can you skip all that?
Can I skip all that?
Can you just do the like dy over dx? Just put it to y because you know it's going to happen.
No, I want you to kick the dx over. Okay, because when we get to more complicated ones of those, you're going to get a point for kicking the dx over.
Why is the integration thing dy?
Because the integral of dy is the same thing as the integral of 1 dy. And anytime I have a constant that I'm integrating, what do we do to this constant?
Multiply times.
We stick a variable on it. And since it's dy, I've got to use the variable y. So 1 dy, if I integrate it, is going to turn into y. Just like on the other side, when I had that 3 by itself, it turned into 3x. And it turns into 3x over there because I got the dx. Alright, so this next one. I want to integrate 4 dx. Should be very easy for us. Brock, what do we get for the integral of 4 dx? What do we do with this 3? Yes, so I need to get, that's going to give me 4x plus c. And what can we do to check? Take the derivative. So what's the derivative of 4x? 4. What's the derivative of c? 0. So it gets me back to where I started. That tells me I did it correctly. If you've got a constant by itself and you integrate, all you're doing is adding the variable that's next to it. Because technically 4 is the same thing as 4 times x to the 0 power. So if I follow my 2 steps process, what's my first step? Add 1 to the exponent. So 1 plus 0 gives me 1, and then what else do I do? Divide by the exponent. So that's going to be 4x to the first divided by 1, which is the same thing as 4x.
So if you just have the s and then the numbers and stuff, is that like just one side of the top one?
Yes.
Sure. Of the dy over dx. So it's not y equals on the second one?
It's just an integral. Alright, next one. I want to integrate x cubed minus 2x plus 5 dx. X cubed minus 2x plus 5 dx. Alright, Chelsea, what's going to happen to the x cubed? Change to x to the 4th. And divide by 4. Okay. What about the 2x? 2x squared divided by 2. What about the 5? 5x. And then don't forget the plus c. You go in there and clean that up a little bit. X to the fourth over 4 minus x squared plus 5x plus c. Again, what can I do if I want to see if I got it right? Take the derivative, and it should end up giving me what I started with.
Why is this called anti-differentiation? Is differentiation a verb? Like taking the derivative?
Taking the derivative is differentiation.
Is that
Process.
the anti-derivative?
What I ended up with is the antiderivative.
Okay.
Anti-differentiation is the process.
Anti-derivative is
Differentiation is the process. Derivative is the end result. Anti-differentiation is the process. The antiderivative is the result.
the antiderivative is just the original thing.
So,
That's what you did with the original.
Antiderivative is what you get after you've done anti-differentiation.
Okay.
Just like the derivative is what you get after you did differentiation.
how have you been sitting there bothered by the
Like 30 seconds.
Next one. I want to integrate 4t cubed plus 6t squared minus 1 dt. 4t cubed plus 6t squared minus 1 dt. All right, Brady.
4t to the fourth over 4. 6t cubed over 3 minus x on
T.
t.
T plus c. Very good. So I'll clean it up. I get t to the fourth plus 2t to the third minus t plus c. Right? So this gives, if I take the derivative of t to the fourth, that gives me 4t cubed. Take the derivative of 2t to the third, gives me 6t squared. Derivative of a negative t gives me a negative 1. Derivative constant is 0. So that tells me we did it correctly. Alex? You have that look.
I mean, I get it.
Don't get it. I get it, but I don't
No,
get
I
it.
get
Is there gonna be sine and cosine?
Yes, there will be sine and cosine.
And here's the next one.
Like, what does it mean?
Next one is that's
Alright, next one. 2 more. I want the integral of the square root of y plus 1 over 2 times the square root of y dy. Alright, Harrison, what do you think?
Square root of y. No. Can you change it to a half and stuff?
That's an excellent idea. First thing I want to do is change this to y to 1/2 and change this one to 1/2 y to the negative 1/2. So if you've got a radical, you want to change it to exponential form, and you want it in the numerator. All right. So what's going to happen to y to the 1/2, Harrison?
It's y to the 1.5
So y to the 3/2.
over 3/2
So if I divide by 3/2, it's the same thing as
multiplied by 2/3.
multiplying by 2/3. Okay. So then I've got 1/2. So on this one, what's my new exponent?
1/2.
1/2. What am I going to divide by?
1/2.
So I want to multiply by
2.
2. So I get 2/3 y to the 3/2 plus y to the 1/2 plus c. Okay, real quick, what's another way I could represent y to the 1/2?
Square root of y.
Square root of y, and what's the trick to finding derivatives of square roots?
Change it to half.
1 over 2 times the radical. So 1 over 2 times the radical. That tells me I did that part right.
Oh.
Alright, one more. I have the integral of x squared plus 2x minus 3 divided by x to the 4th plus, times dx. So the integral of x squared plus 2x minus 3 divided by x to the 4th dx. Thoughts on this one?
So quotient rule.
Quotient rule is no quotient rule.
So that's eccentric.
That's awesome.
You want us to do the opposite?
Do the top and then do the bottom.
Is there something you have?
What do you mean by split it?
Like do x squared plus 2x minus 3 times 1 over x to the fourth.
Don't want to do that, but you're thinking about it correctly. You're doing something simple.
Move it to the
Couldn't
top.
you just do
Cancel.
the top first and then the bottom?
Can't do that either.
Move
Move
it
it
to
to
the
the
top.
top.
Be the same as x to the negative.
Move it to the top.
Say it
and
again.
You could
Okay, you subtract the 4
So what would I end up
with x to the negative 2 plus 2x minus 3. That will do.
You're close.
When-
You got to do it to each one.
Plus
of
2
them.
x to the negative 3.
What I want to do is, if I have a polynomial divided by a monomial, is I want to divide each one of these things by the bottom. So I want x squared over x to the fourth plus 2x over x to the fourth minus 3 over x to the fourth. So then I want to reduce it and then make sure everything's in the numerator.
So many ways.
So x squared over x to the fourth, what is that going to end up giving me?
X to the negative.
That gives me x 1 over x squared, which is the same thing as x to the negative 2. What does the next one give me?
2x negative 3.
2x to the negative 3.
Just subtracting.
And the last one,
3x to the negative
3x to the negative 4. Once I've done that, now I'm in a situation where I can integrate. So what's my new exponent on x to the negative 2?
Negative 1.
Negative 1. And divide by the negative 1. My new exponent on the next one? Negative 2. Divide by the negative 2. The next one?
Negative 3.
Negative 3. Divide by the negative 3. Don't forget about the plus c. Then what do I need to do to clean it up?
Negative, or make everything go where it's
Yeah,
supposed to.
negative exponent. I don't want negative exponents, so we're going to give the negative 1 over x minus 1 over x squared plus 1 over x cubed plus c.
Could you do it 1 over all of the ones in the bottom since it was.
Nope.
Okay.
I'd have to get a common denominator to be able to do that.
Alright.
If you leave the negative exponents, is that wrong?
Technically, I guess not, but I don't want negative exponents, so you're going to move on.
So like on a test, if you forget.
They will never give you multiple choice answers with negative exponents in them. So move on. Alright, so 2 steps in basic anti-differentiation. Step 1, add 1 to the exponent. Step 2, divide by the exponent. There it is.